what's the empirical formula? Once you know the percent compound and you go on to like empirical formula, what is that? What's the empirical formula? Does anyone know? What is that? Okay, so yeah, H2, that's the empirical formula, right? So what is that? What is that comprised of? What does that mean? When someone says, oh, solve for the empirical formula, what are we looking for? When we look at that. Does anyone know? What exactly are we trying to find? Yes, so you're looking for the lowest amount of each element within a whole compound. Looking at the smallest whole number exactly, by the way. For example, okay, I just want to ask, if we have CH 1.5, can that happen? Does that exist? Can we do that? Would that work or would that not work? No. Yes, exactly. And it doesn't work because you have to have the whole number of something. This is why, of course, you guys know this, right? You never see CH 1.5. That would never happen. It's because it's the smallest whole number ratio of each element within a whole compound. Speaking of which, formulas of all what are what? What kind of compounds are we looking at? Of nearly all what type of compounds? Does anyone know? Speaking about empirical formulas of what kind of compounds? You just guessing, you don't know. Like if you just want to say something. Metallic, ionic, covalent, polar, nonpolar. Like what kind of compounds are we looking at? Formulas of all what? Nearly all are what?
Is it ionic?
Yes, ionic. Okay. And what about them? Formulas of all ionic compounds are what? Does anyone know? Ionic compounds are what? What are ionic compounds mostly made of?
Oh,
or mostly what?
That sign is sign.
Does anyone know? Ionic compounds are mainly.
Oh my god.
No, if you don't know, just write it right now so I can see it, and then I can talk to you guys about it. So ionic compounds are
like metal.
It's a formula. So is it molecular or empirical formulas? That we're filling in the blank here. Is it empirical or molecular? Just guess. If you don't know, take your best guess. Molecular, empirical? Okay. So actually, it's gonna be empirical. And does anyone know why it's empirical?
Molecular is covalent.
Yes, no, I don't know. Because it seems like you guys, I think, are just guessing with the question mark. So the reason that most ionic compounds are just gonna be empirical is because of formula units. Ionic compounds mainly have formula units, which means it has the smallest or fewest number of cations and anions with no formal charge. And because of that, it'll have the because it's the smallest number of cations and anions is the same definition as an empirical formula, the smallest amount of a mole ratio in a compound. So that's why ionic compounds are almost always going to be empirical instead of like molecular where you can reduce it down. And then speaking of which, how do you calculate empirical formulas from percent compositions? So once you have an element such as CO2 and you have the percent compositions, so C is going to be like 25%, for example, and then the other two are like, I don't know, some other stuff. What would that be then? What do you do once you find the percent compositions of C and H2? H2. What do you do with that? How do you take the percent compositions and turn that into an empirical formula? Does anyone know what you do? So once you have the percent, you have like 25. What do you do with that 25? Right? Because it's not in a formula yet, right? So how do we convert that? What do we do with that percentage? Something with the molar mass. Okay. Well, you're right. What else do we do with that though? Something to do with the molar masses. Yes, exactly. And you do that using, with dimensional, yes, exactly. So what you're going to do is actually use all three of those, molar mass and dimensional analysis. And what you're going to do is you take that mass and then you turn it into equivalent numbers of moles. And by using the masses that you have from like C and H2, you can find the masses, right? Because you have the molar mass. You can use that to find the moles. And then once you find the moles, you can divide by using again, the molar mass from the masses that you're given from the percent compositions to find the empirical formula. Does that make sense? So you're basically, your answers were right. You just need to put them all together, pretty much.
Yeah.
Do we have any questions? This chapter is not that bad. It's just a lot of conceptuals. So those are the answers in case you are wondering. And then, okay, so an example. Which pairs of the following compounds have the same percent composition? So we have ethine, iocosane, isolene, and benzyne. So which one of these have the same percent composition?
So
We have C2H4, C20H40, C2H2, and then C6H6.
Or is it 2-4-2-2?
So which one of these, or if there's multiple ones, have the same percent composition? So you can say, oh, all of them, only two, and just say which ones are. Does anyone have an answer? C2H4, A, B, and C. Okay, so Natalie says A and B together, C and D. I'm not sure. Okay, does anyone else have an answer? C, B, and then C. Okay.
Yeah, I was gonna say the same.
And then anyone else? Can I get one more answer? Because it's pretty interesting right now. Okay, does anyone else have an answer? Which ones have the same percent? Okay, same answer. Okay, so actually, yes, T and Natalie are correct. A and B are the same, and then C and D are the same. And the reason for that is if you're confused. Can anyone tell me why A and B go together? And you'll see the pattern once I show you why. But does anyone know why A and B? How'd you get that? The ratios.
Yeah.
Okay, what's the ratio? C2H4, C20H. 1 to 2, exactly. C and then H. Because as you can see, C20H4, that's just a molecular composition. Same thing with ethane. They both reduce to just 1. C1H2. Same thing with C20H40. It's just the same thing. So they're both molecular formulas, but once you reduce them, you get the same amount, same molar ratio. And then for C and D, why are those two together? Why are those two having the same percent composition? Can anyone tell me why? What's their molar ratio? Or if they're different, what is that? Both 1 to 1, exactly. Because it just reduces down to just C, H, CH, right? Because you can divide D by 6 and then C by 2. So those again are both molecular formulas, but if you reduce it down, you just get the empirical formula, which is just CH, just regular 1 and 1. So that's why A and B go together and then C and D go together. See, it's pretty simple, right? So do we have any questions? I'm gonna assume that's a no. Okay, so let's just keep going. So yeah, A and B have the same empirical formula, and then C2, just C, and then D have the same empirical formula, which is CH and then CH2. Okay, so now that we've done that, let's do the next one. What's the percent composition of mineral phosphorite, which is Mg2SiO4? So what do we do with this? What's the first thing we do? Does anyone know? From this formula, how do we calculate percent composition of this? Mineral phosphorite. Does anyone know what's the first thing we're gonna do? Does anyone take a guess? What do we do? We have 2 Mg, 1 Si, and then O4. So what do we do with this information? Does anyone have to find the mole first? Exactly. So how do we find the mole of this?
Okay.
Or the mole of Mg to start with? How do we do that? What's the first thing we're gonna do? What can we get from just this part? What are we gonna do with that? Does anyone know? How do you find the moles from that? We have 2 Mg's, right? So what do we do? It's actually pretty simple. It uses the molar mass.
Okay.
So what do we take that molar mass with? Does anyone know the answer to that? What do we multiply it times? With the 1 mole. Molar and use the molar mass. Okay, So yes, we are gonna find the moles and using the molar mass. With the 1 mole, actually, from this, we actually have 2 moles. We have 2 moles because it's Mg2,
Oh.
not 1. And this is in a chemical equilibrium type of equation, so it's just gonna be 2, not 1 mole. So there's 2 right there, that's the
Okay.
little subscripts, as you can see.
Okay.
So you have 2 moles of Mg, So we have out 2 moles with Mg, and then what are we gonna do next? What are we gonna multiply it times? The molar mass, right? So what's the molar mass of Mg? Right, as said by
Oh.
Braylon, molar mass. What's the molar mass of Mg? And this is just straight up, just off the periodic table. So what's that going to be then? 24.31. Okay, so when you multiply that, what do you get? 24.31 times 2. What's the answer? And then we can also do the same for Si and then O4, right? Because it's the same process. So 1 mole over here. And then 4 moles of oxygen, right? So what do we get when we multiply again? 24.31 times 2, what do we get? Just plug that into your calculator. Or on your phone or something. What's that going to be? Does anyone know? That's 48.62. And then what about moles of Si? What do we get? What do we multiply that times? What's the molar mass of Si? Does anyone know or remember or want to remember? What is that going to be? 1 mole of Si. 28.01, yes, exactly. And so that's just going to be 09, right? So what about oxygen? What's the molar mass of oxygen?
4 times 16.
Yes, and I'm actually just going to round that to just 16 because I think it's easier to work with instead of like a bunch of decimals. But yeah, that's correct too. You can also use 15.999 if you like. So once we have this, so now we have the grams, right? The grams of each element. What do we do now? Because we have all the masses, right? So according to each mole. So what do we do next? We have each individual amount. So what do we do?
Wait, are these in
You multiplied all of them, right? So what do you do? It's the same thing as natural abundance. What are you going to do next? We find. What's that going to be? What's that going to be equal to?
Yeah, okay,
Okay, actually, we're going to do something else. We're not going to divide just yet. So, because we're not finding empirical formula, we're finding percent composition. You're getting confused between the two. What do we do next? Does anyone know? Empirical formula, you divide by the lowest one. But for percent composition, we want to find the percent of Mg. So what do we do once we find the masses? Does anyone know? Yes, no, I don't know. You can just write it down. Like, oh, I don't know. You don't know. Okay, yes, well, actually, yes, you add them together. Once you add them together, what do you get? Because for this, okay, I'm just going to write this out. Step 1, you're finding the molar mass. That's all we're doing. So for this, you're just finding the molar mass. That's all you have to do. So this part's not complicated because all you're doing is just finding, oh, how much this whole thing is. So it's not that bad. So once you add it all together, what do you get? What's the answer? Yes, exactly. 140.71. Okay, what do we do now that we have that? We have the molar mass of Mg2SiO4, right? What do we do with that molar mass? What do we do next? Because we have each individual mass now, right? And we found the molar mass of the entire composition. So what do we do next? Yes, exactly. Yes. So what do we do next? 48.62 divided by 140.71, right? So you're going to do that same thing for each of them, and then is that the only thing you do? You just divide it, and then that's it? What do you have to do with it when you're doing percent composition? Does anyone remember? Yes, you have to multiply times 100 as well. You do all the steps together, divide by the complete molar mass, and then you times it by 100. So once you do all that, what's the percent of Mg? What's that going to be? 48.62 divided by 148.71 times 100. Does anyone know the answer to that? What's that going to be? And then you can repeat the steps for this one, and then repeat the steps for oxygen as well. So what are we going to get when you do that? 35.40. 34.5, sorry. Yes, that's correct. And then what do we get for SI? Once you do all that, what do you get? 28.09 divided by 140.71 times 100. What's the answer? Does anyone know? What do we do from that? Because you're just putting it into your calculator, so what is that going to be? Anytime. So, does anyone have an answer? 19.96. Yes, exactly. And then what about the last one? What are we going to get from that?
I haven't even started the calculation yet.
And feel free again, like if you guys want to just use your microphones so you don't have to keep writing it in the chat if you want, because it's faster. I don't think anyone here is going to judge you. So, what about the last one? 64 divided by 140.71 times 100. 45. Yes, exactly. 45.48%. So, yeah, that's it. See, it's pretty easy, right? You're just finding the mass of each element by the moles, as you can see. Pretty easy stuff, and then adding it all together, dividing by the molar mass, and then timesing it by 100. So that's percent composition. So, are we good on that? Yes, no, I don't know. Pretty easy, right? It's pretty easy stuff, I think. So are we all good on that? Yes, okay. Right, and so this is the answer if you want to see it a little nicer, I guess. But we did essentially the same thing. And then, next one. What's the percent composition of this? And this one I'm not going to write out because I just think it's really easy. And we just did one where you did the same thing. So I'm just going to have you guys tell me what percent you get. Right? And we all know the mass of just a singular carbon is going to be 12, right? Or 12.01. And then we have H, which is just 1.01. Nitrogen, which is 14.01, and then oxygen, which is 16. So knowing this, what's the percent composition of each? Yeah. So what are we going to do? How do we do this?
Molar mass. Wait, what is this?
Can anyone tell me what do you do? So we just did this, right? So it's just a different compound this time. So what are we going to do this time? Can anyone tell me?
So what do we do there?
So we have C equals 22, right? So what do we do with that?
No.
Does anyone know?
22
Yes? No? I don't know.
times 12.
What do we do with C 22?
1.
You can multiply to find the molar mass of the total compound, and then you have to multiply each element by how many, like say you did carbon, it's 22, so you have to multiply to find how much carbon is in the compound.
Okay, so knowing that, 22 times what? Because you said you have to multiply times the math, right? So 22 times.
I assume you do 22 times 12.1.
Yeah, so once you've done that, what do you do next? What's the number? Does anyone know? Yes, exactly. So what do you do with that number? 264.22. What do we do with that? Because I believe Braylon just said you divide by the molar mass, right? What's the molar mass of the whole thing? C22, H24, N2O8. What's the molar mass? Yes, exactly. So what do you do with that? 264.22. What do we do with that? right? Because this is the molar mass of just C, right? But we want the whole compound, so what are we going to do with that?
You divide 264 by the total molar mass.
Yes, and that's
And
40.
then multiply by 100, I think.
Yes, exactly. So what do we get?
Oh.
59. Yes, exactly. So what about the rest of them? What's H? Because the first one, C, is 59.44, right? I know this seems really tedious, like, oh, I know how to do this and stuff. But it's just good to get the practice in because your test is coming sooner than you would think. 24.24. For H? Are you sure about that? 5.40. Yes, T is right. It's actually 5.45. Natalie, I think you might have forgotten to divide. And then, what about N? What do we get for N?
Oh my gosh, she's going way so fast.
Does anyone know? 14.01. Yes, exactly. 6.3. And then what about oxygen? It's just the same process every time, right? So what is that going to be then? Does anyone know? Yes, exactly. Yes. So do we have any questions on that? Pretty easy, right? It's just the same thing again. Are we good? Yes? Yes? Okay. So I'm going to take the residues. Okay, so let's just keep going then. That's the answer. And then when you guys do some tests, it'll be like way faster, I'm sure. So an empirical formula provides the what mole ratios of the blank and the what.
This is a very
This is kind of like sparse, but an empirical formula provides what? What about the mole ratios? What do we characterize about them? Does anyone remember? Empirical formulas you can't reduce, right? Which makes them the what? Mole ratios. They are the what? Smallest, biggest. Wait, what? I'm sorry.
The least amount of
Yeah. Or you say the simplest. Because it's, so again, the most reduced, most simplified one.
Oh,
So you can say simplified. And then found in what? Ratios of what? What are we simplifying? We're looking at what more ratios of what?
reduced.
So you remember?
Mole.
The simplest mole ratios of, what are we examining? What are we looking at? Does anyone know? Ratios of the simplest mole ratios of what? What are we looking at?
Element?
We have CH2. What are we looking at? We're looking at, oh, it's 1 to 2. We're looking at the, if you don't know, again, if you guys don't know the answer, you can just write I don't know in the chat.
Is it the mole ratios of the element in a compound? I don't
Yes,
know.
exactly. Yep, correct. Yeah, you're right. Exactly. See, there you got it. So elements and a compound. I can't really write on here, but yeah, elements and a compound. So once we've done that, how are molecular formulas different from empirical formulas? What's the difference? They're asking for molecular. How does that differ from the empirical ones you're gonna find?
Isn't it even more?
Does anyone know?
It's not more reduced.
What's the difference? Do we know? I don't know if you guys are just confused or like, I feel like you guys are confused, but I'm not sure. So,
I forgot.
do we not know? Again, if you guys don't know, I forgot. Okay, molecular formulas you can reduce down. It will be like, instead of seeing CH or something, you have C 2 and then H will be 8 or something, yeah. Yeah, of course, Verlin. That's fine. Thank you for answering. But molecular formulas differ from empirical because they can be reduced. Empirical is just the standard, most simplified amount. You can't get any lower than that. It's the standard. Like what it is what it is. Molecular, you can simplify it more and more and more. So that's the difference. So how do you calculate molecular formula? If you have the empirical, how do you change it to get the molecular? Does anyone know? Yes, no? How do you find, if I have the empirical formula, how do you find the molecular from that? What's the formula we have? I forgot. Okay, so it's just going to be this times n. And N pretty much represents when you do percent compositions. And that's what I think Natalie said before when we got confused. You're just dividing again by the lowest molecular amount, and that's how you find the N. So N can be like 2, 4, 8, anything, yeah. And then you multiply that, and that's how you get the molecular formula. It's basically empirical, just times N, pretty much, using a molecular mass or a molar mass. So can molecular mass be, or formula be the same as empirical? Yes or no? Yes, okay. And then why is that? Why can molecular mass be the same as empirical? What's the reasoning behind that? Does anyone know? Yes? No idea. Okay, so molecular formula can be the same as empirical because of the subscripts. If the subscripts can't be reduced more than they already have, then it can be the same molecular formula. For example, you have, let's see, CH2O. You can't go further than that, right? Because you have 1, 2, and 1. You can't reduce that any further than just 1, 2, 1. There's no other similar factor that you can use to change this whole formula. Therefore, it's just going to be the same thing. Versus, what's it called, C2H8. You can change that and be like, oh, it's going to be C1 and then H4, right? So you would know the difference. So that would be molecular, but then this would be empirical. The subscript here will not change, so this can be both molecular and be empirical. Do we have any questions?
No.
Yes? No? I'm gonna take that as a no. Okay. You guys are awfully quiet. Okay. So next, what do the following compounds have empirical formulas that match their molecular formulas? So which one has the same empirical and molecular that we just discussed? Which one would that be? Looking at 1, 2, and 3. C2H6O2, C3H8O, or glucose, which we all know. So which one? It's gonna have the same empirical and molecular. 2. Okay, does anyone else have an answer? I have 2. And then is someone else gonna say something? Like, oh, I think it's 1 or it's 2 or 3 or what do we think? What else? Does anyone else have an answer? Yes? 1 and 3? Okay. Does anyone else have an answer? Because we're differing right now, right? 2, and then someone else said 1 and 3. 2. Okay. So the correct, how do you tell by looking at it? Okay. So with this, so one of these is going to be the same for both molecular and empirical, right? So when you look at 1, can that be reduced further? C2H6O2, can that be reduced? Yes or no?
Oh.
Yes, exactly. And what does that get reduced to? What do we get when we do this? Because it can be reduced by 2, right? So what's the formula going to be?
H3.
Yes, exactly. C1H3 and then O1, right? So from that it can be reduced, which means that it can't be the same formula because these are 2 different ones, right? This is the molecular one. This is the empirical, because empirical is the most reduced one. Molecular is the one that can be reduced. So these have 2 separate formulas, which means they can't be the same. Therefore, one cannot be it. So that, and then the same thing goes with glucose. It can be reduced further, right, by 6. So that's going to be 1, H will be 2, and then O will be 1 again. Same thing. There's 2 formulas. One's the most reduced, which is C1H2O, and then the other one can be reduced. Therefore, those 2 different formulas are there, which means that they both can't be the same because one's more reduced than the other one. So they can't be both the molecular and empirical. This one's and then this one is molecular. Therefore, since there's 2 formulas, then it doesn't work. This one's out then. But isopropanol, C3H8O, what can that be reduced by? What number? Can anyone tell me? You just write it in the chat. What can that be reduced by?
Which one?
Does anyone know? You can say I don't know if you don't know. What can that be reduced by? C3H8O.
Nothing? Nothing?
Nothing. Yes, exactly nothing. Because of this, that's the only answer it could be. There's nothing else to reduce by. There's nothing that you can, oh, I can divide it by this or that. Nothing. It's just C3H8O. That's it. That's why 2 would be the correct answer. Because there's no other formula it can be reduced down to. That's it. So it's both the molecular and empirical formula. So do you guys understand that? Are we good on that? Steven, are you good on that? I think. Okay. Good. Alright. Yes. Nice. Yep, only B. And then this one. This is a really long equation, but I promise you it's not that hard. Okay, percent. So you're looking for the molecular formula of E-iodine, right? So you have 83.63% of C, 14.37% of H. So you have the molecular mass of 280U. So how do you find the molecular formula of iodine? Can anyone tell me what are we going to do? Does anyone know? Because we have this, right? This is the first value we have. So what are we going to do with 83.63? It's the same thing as percent composition. So what are we going to do? We have that part, right? So what are you going to do with that?
Wait.
Does anyone remember? Anyone at all? You can just say, you can just guess. If you don't know, you can just guess. To fill the awkward void of silence. So, does anyone know? What do? You have 85.63. What do we do with that amount? What are we going to do? Oh, carbon, right? Does anyone know? If you don't know, just write I don't know.
Find the mole.
Find the mole. Okay, exactly. Find the mole. How do you do that? How do you find the mole at the end of this? Right, because you're given the percent. How do you get the mole? Again, if you guys don't know, just write I don't know. It fills the awkward void much better.
Is it 1 mole?
One mole.
Like that?
Yes, exactly. 1 mole times molar mass. So what's the molar mass of C?
C is.
Does anyone know carbon? What's the molar mass of carbon? 12 point. Yes, exactly. So once we do that, I'm just gonna do the math so we can go a bit faster on this. It's gonna be 7.130 when you divide that. And then what about 14.37? What's the mass of hydrogen?
1.4.
What's that gonna be? Yes, 1.008. So once we do that, our answer is gonna be 14.26. Okay, so once we've done that, what do we do? Because we have the moles now, right? These are both moles. So what do we do with that information? We can find something. What can we find? Can anyone tell me now that we have this answer? What do we do? What's the answer that we can find? 7.136 and then 14.26. Does anyone know? This is carbon. This is hydrogen. Yes? No? I don't know. You can just write it down in the chat like, oh, I don't know what to do next. Can you just tell me or something? And then I can help you guys out.
Okay.
So, you don't know. Okay. So with this, you're going to divide by the smallest one, right?
Okay.
So when you divide this, what do you get? 7.130 divided by 14.26. What do you get?
14.1. Wait.
Because if C is the smallest, then we're going to keep C as just 1, right? So what's H going to be? Once you divide 14.26 by 7.130, what do you get? Can anyone tell me?
2?
You can also just do the whole numbers. 2 exactly, yes. So it's going to be CH2. So once we have that, we can find, that's the empirical formula. So we have the empirical. What do we do now? Okay. Does anyone know? because we have this, right? So here, I'm just gonna explain this part because I don't think you guys know it yet. But C, you have C, right? You're gonna take one, because you have 1 mole of C, 1 C, right? Take that, you're gonna multiply that times the molar mass, which is just regular C, because you only have 1 C, right? 12.01 over 1. And once we do that, you're gonna add that.
Wait.
And then you're gonna do the same thing with H, except we have 2 H's, right? So you're gonna do 2 times the molar mass, which we had up here, 1.008 divided by 1. And once you do that, what's the answer gonna be? What do you get? What's your final mass? 2 times 1.009 and then 12. What do you do when you add those together? What's your answer? What's that answer gonna be? Does anyone know? You can plug it into your calculator or something. So what do you guys get when you multiply all that together? 24.21. I think you might have multiplied or did something wrong. I think you multiplied by accident. You're doing 12 plus the 2
Is it 14?
times 1. Yeah, I think you accidentally. Yeah, there. Yes, 14. There you go. Yeah, I think you accidentally multiplied it. But yes, it's gonna be 14. 14.03 to be exact. So once you have 14.03, what do we do? Now we have the full mass, right? But then we also have 280. So what do we do with that 280? What are we gonna do? Yes, exactly. 2 divided by 14.03. And what's the answer? What do we get when we do that? We get, what do we get? What's the answer gonna be? 280 divided by 14.03. 20. Yes, exactly. So what's our molecular formula gonna be? Because this equals N, right? That equals N, and this is our empirical formula. What's the molecular formula gonna be then? Yes, exactly. C20H40. Okay. That's it. Do we understand? Yes? So this is your final answer. Pretty easy, right? I think you just have to memorize the steps. I think the reason why some of you might not understand this is because there's a lot of things, empirical, molecular, percent composition, you have to switch in between each one. Now going from percent composition to molecular, if you're doing percent, like you have 85.63 and you need to get to molecular, you have to do empirical in between. Once you do empirical in between, you can get to molecular. It's very rare you can just like skip over all that. So with this, you just have to memorize the steps you have to do for each thing. Percent composition, how do I do that? Empirical, how do I do that? Molecular, it's just easy. You just have to do empirical and then use empirical to get to molecular, which is just multiplying times n, usually. So, are we good on this? Do we understand? Yes? No? Yes, okay. And that's the answer to that. Okay, combustion analysis. Okay, what is combustion analysis? Can anyone answer that? This is 8.1, so I think you guys learned this yesterday. Now, I'm not sure how far we're gonna get on this, but we'll see. Combustion analysis, what is that? Does anyone know? Yes? No? I don't know. Can anyone tell me what that is? We know? It is combustion analysis. Combustion, right? Something blows up into flame. Right? What do you do with that information? Does anyone know? This is from your textbook, I believe. So if you don't know, it's pretty simple. It's on there. Does anyone know what's combustion analysis? What's that gonna be? It's the use of fuel and oxygen, right? So if you don't know, you can just write I don't know, or no, or yes. Does anyone have an answer?
I Okay.
You don't know. Okay, so combustion analysis is the complete combustion or like blowing up of something, of a compound, so that after you blow it up or it blows itself up or whatever, just blows up, you're analyzing the compound itself afterwards, of the products, to find the chemical composition of that compound when it was still together. So if you have, I always use CH2, so let's use that. You have CH2 and let's say you blow it up, right? And so it's everywhere. You have like, so all you have left is just C and then you have H and then H. Chemical analyzation is what it does is it analyzes, oh, this is a C, this is, and this is C, this is H, and this is H. So what they do is they take all those elements and then they try to piece together and analyze what was the chemical composition before it blew up or before it combusted, what that chemical composition of that compound was. And then once they do that, they put those all together and they're like, oh, that's CH2. So it's just analyzing the products or the aftermath of the combustion. Do we understand that? Yes? Okay. So what's the combustion analysis must be carried out by an excess of what? What are we looking for? Combustion analysis must be carried out with an excess of, right? Because if we have an equation, we have all the elements, reactants on this side, the products. What's one of the products that are in excess? Does anyone know? Yes, no, I don't know. Does anyone remember? It's an element, I'll give you that hint. Does anyone know what element that would be? Yes? No? Carbon? You're close to it. It's a little further. So what do we have? We have carbon, anything else? Does anyone know? Yes, no, I don't know. Oxygen. Yes, exactly, oxygen. So combustion analysis must be carried out by oxygen. So once we have that, let's answer the third one. In combustion analysis, all of the carbon is converted to what? And then hydrogen is converted to what? Do we know? What is that going to be? Carbon is converted to what? What compound has carbon in it that we know of? Does anyone know? If you don't know, you just I don't know. Just so that I would know. See, gas. Yeah, it's a gas converted to. Okay, I'm just gonna say it because I don't think you guys know it, but it's gonna be CO2, so carbon dioxide, and then hydrogen's gonna be converted to not a gas but a liquid. It's gonna be converted to H2O. So CH2 and then H2O. So when you have combustion analysis and it asks you a problem about that, you're gonna know it's combustion because it's gonna be carbon and it's gonna be converted to CO2 and then hydrogen is gonna be converted to an H2O, which is a liquid. That's what combination analysis is pretty much doing. A fuel and an oxygen used together most of the time, like methane or again carbon or some other stuff. So we're good on that? Combustion analysis, yes. Okay. And that's the answer to that. And then I just realized I didn't give you guys the attendance link, so I'm gonna copy that and put it into the chat so that you guys can sign that if you were here. So please click that and sign that if you are here, pretty much so that the system knows that, oh, the student was here at this SI session. So we're good on that, and then we're gonna do this problem. Okay, this one's actually pretty long, so I don't know how far we're gonna get with this, but we can see. I'll just help you guys along the way. So with this, we have the masses of CO2 and H2O. So what do we do with that? 5 grams, right? So what do? You need to find the what? Are we looking for all of CO2 or are we looking for specific elements? Because you're looking for only carbon, hydrogen, and oxygen, right? So what of CO2 are we looking for? Carbon or oxygen? Are we looking for carbon or are we looking for oxygen? Does anyone know? Yes? No? I don't know. Carbon. Yes, exactly. So we're going to take 2.360 And then what are we going to do with it? Because we're trying to find carbon, right? So what are we going to do? What are we going to divide by? We're doing carbon, right? And then we have CO2, which means we're going to divide by the molar mass. What's the molar mass of CO2? Does anyone know what that would be? 44, yes, exactly. 44.01 to be exact. So once you do that, you have 1 on top, then you're not done yet, right? Because you still have to look at, you're looking specifically for the carbon, but you have CO2. So you can look at the moles. How many moles of carbon do we have in CO2? Can anyone tell? In CO2, how many carbons do we have? 1. Exactly, 1, right? And then how many of the whole moles of CO2 do we have? We have 1, right? So this is 1 mole of CO2, and the other one is a mole of just carbon, right? 1 mole, just carbon. So when we multiply that, what do we get? It's just 2.360 divided by 44.01. What do we get? Does anyone know? You're just dividing. So what do we get with that? And then the same, we'll just do that same thing for hydrogen. Yes, 0.05362. So what about this one? We have of H2O. What are we going to do with that? Does anyone know? What's the what are we dividing the molar mass, right? So what's the molar mass of CO2? I mean H2O. Sorry, H2O. What's the molar mass? Does anyone remember? What's that going to be? What's the molar mass of H2O? Do we know that? 18. Yes. So 18. So once we do that, how many moles of hydrogen do we have in H2O? Moles of hydrogen. 2, right? So we have 2 moles hydrogen and then 1 mole of H2O. So once we have 1 mole of H2O and 2 moles of hydrogen, what's that going to equal? What are we going to get? What's that going to be? Right, because you're just going to divide 0.640 divided by 18 and then multiply it times 2. So what do we get when you put that into the calculator? Does anyone remember what do we get? I'll just prepare for that. So this is C, right? So we have carbon over here. What do we get for hydrogen? Yes. It's from knowing that there's only one H2O. There's only one of it, that's why. Then the moles of hydrogen come from the fact that there's 2 hydrogens in H2O. It's kind of just doing per thing. So in one H2O, you have 2 moles of hydrogen. That's pretty much what it's saying. Because you're looking at it individually, that's pretty much it. So once we do that, what do we get? When you do this whole thing, what do you get? Does anyone remember? Do you know? Yes, no, I don't know. Get points? Does no one have a calculator on hand? Okay, thank you. So I was getting scared and I was like, wow, I don't think anyone has a calculator out. Okay, so that's of H. So now that we have that, what do? What do we do with the 0.05362? What do we do with that answer? Because next we have to find the mass. So what do you multiply it times? Because if this is just of carbon, what do you multiply that times? What do we multiply that with? Just carbon, right? So what's the molar mass of carbon? Does anyone know? What's the molar mass of just carbon? Yes, thank you. Okay, so it's going to be 12.01 grams divided by just 1 mole of C, right? Because we're only looking at 1 C in CO2. So that's going to be, and I'm just going to answer this because it just takes too long to ask. So I'm just going to, we only have like 5 minutes left. So I'll just do that part for you guys. About hydrogen, what's that going to be then? What are we going to multiply that times? Can anyone tell me?
Wait, molar
Because we
mass?
have 1 here, right? 12.01. So what about hydrogen? Molar mass H. Yes, so it's going to be 1.008 over 1, which means it's going to stay pretty much near the same. So once we have all of that, what are we going to do next? What do you do with these two answers? Right? What do we do? Does anyone know? These two answers right here. We have the masses of both. So what do you do with both masses? What are we going to do? Does anyone know? You're gonna, what? You're gonna do what? Operation, add them. Yes, exactly. So what do you do once you add them? And I'm just gonna erase this because I think let's clear that. So what do you do once you add those two? Did I erase it too fast? Maybe you guys didn't see it. You don't know or something, you just write I don't know. Subtract by 1. Yes, almost. So you can do 1 subtracted by that amount. So it's going to be 1 time minus 0.7156, which is what happens when you add those two together. There's the 0.07 plus the 0.6 something, I forgot. But you're going to do 1 minus 0.7156. With that, you get 0.2844 grams of oxygen. And once you do that, what do you do with this? Because this is the amount of oxygen we have, right? So what do? Now they have oxygen, just as they had done before, times by 16. Actually, you're not multiplying times 16. You're going to do something else. What are you going to do? It includes 16, but you're not multiplying it. You're what? Dividing it. Yes, exactly. That's because you're trying to find, you're trying to find the moles. So we have to do mole 0 over 16 grams. And then from that we get what? Does anyone know? When you put on the calculator, what do you get?
0.28.
Can anyone tell me if you take 0.2844 divided by 16, what do we get from that? Yes, exactly. 0.0178. And that's for oxygen, right? And if you guys can't remember, I'll write down what it was for carbon. So that'd be 0.05362. And this is for carbon. Then this up here, as we know, that's for oxygen, right? And then for hydrogen, we had 0.07103. So now that we have the masses, or the moles really, for all of them, what do we do? What do we do with all of these? What are we going to do? Does anyone know? We're going to do the same thing to all of them. What are we going to do? You have all 3 of these moles, so what are you going to do with them? Does anyone know? What are you going to do? If you don't know, you just write, I don't know. That's exactly, you divide it by the smallest one, which is going to be 0.0178, right? So when you divide all of them by 0.0178, what are you going to do? What's the answer? Oxygen's going to be 1, right? So what about the rest of them? What do you get for C? And then what do you get for hydrogen? So one oxygen, how many carbons do we get, and then how many hydrogens do we get? How much is this going to equal? And then how much is hydrogen going to equal? When you divide it by 0.0178, does anyone know? What do you do? What's the answer? How many moles of C do you get? You just put that into your calculator. So what do you do? Once you put that into the calculator, how many moles of carbon do we have? Calculator. Okay. Does anyone else know that? 0.05362 divided by 0.0178. What's the answer? This is the last problem we're gonna do too, so you guys are almost finished, I promise. So what do you get when you divide it? What do you get? Does anyone else know? 3. Yes. What about hydrogen? What do we get? What's the answer gonna be? 0.07103 divided by 0.0178. What do you get from that? 4. Yes, exactly. So the answer is gonna be what? Because we have 1 oxygen, 3 carbon, and 4 hydrogens, right? So what's that gonna be? What's the molecular, empirical formula gonna be? You multiply that all together, or write it out. What's that gonna look like? Can someone write it in the chat really fast? What's that gonna look like? Yes, exactly. You guys are both right. C3H4O. That's how you find it. This one was kind of long, but it pretty much shows you that if you only have these, if you don't have the oxygen amount, you can find it by subtracting 1. So 1 minus whatever you found from carbon and hydrogen, you add those, and you subtract it, you can find the oxygen from this. And then from that, you can find the amount, the masses, and then divide by the smallest and get the empirical. So I think that's pretty much it for today.